Guten Morgen, guten Tag, guten Abend. We will use satellite imagery to evaluate the change in terrestrial water storage over a piece of land through time. This will allow us to see changes in groundwater storage, changes in glacier and snowpack, and generally changes in water storage. We will do this using Google Earth Engine and the GRACE satellite project. Let us begin by looking for the GRACE data product on Google Earth Engine. We together type in GRACE, G-R-A-C-E, Earth Engine, E-A-R-T-H, space Engine, E-N-G-I-N-E, and enter. We are looking for the link that says GRACE Monthly Mass Grids Land. Finding this, we click. Scrolling down, we see a description in the description tab. GRACE TELUS monthly mass grids provide monthly gravitational anomalies, that is, the changes in Earth's gravitational field relative to a time period. So relative to this time period, it's saying how is the gravitational field different at different points in time. This allows us to see the changes in water storage through time, as influxes and changes in water storage are, at least on land, one of the main reasons for changes in gravitational anomalies, which are a response to changes in mass on land. So when there is more water, groundwater, surface water, on a piece of land, it will have a greater gravitational pull than when it has less groundwater, less glaciers, less soil moisture. We scroll down and we see Open Encode Editor. At this point, if one does not yet have Google Earth Engine, they will be prompted to sign up for an account. You're welcome to use an institutional email address, any email address. You are not restricted to Gmail. A short description of how you will use Earth Engine, and shortly thereafter will be provided an account. Once one has an account, clicking on the link will take us to something that looks like this. We have 3 columns. On the left is a collection of our different scripts and uploaded data. It will look slightly different than this. In the middle is where we write our code, open our code, and on the very right is like a terminal that shows the current status of code that's running or data that's uploading. And the bottom is a map, which we won't take opportunity of in this session. Let us demonstrate the change in water storage through time over 2 different countries. One is welcome to use any country, any region, any basin, overlaying area of any aquifer. We will search and download the shape files, the outlines for 2 countries, but this process can be repeated again for any region of interest. I'm currently in the country of Austria, so we'll show it for Austria, and an interesting country to also evaluate the change in terrestrial water storage through time is Saudi Arabia. So we will look both at Austria and Saudi Arabia. Let us look for a shape file for the country of Austria, a shape file or the outline of the country of Austria. So I'm going to look up Austria shape file. This link, Austria shapefile European Environment Agency, I'm going to click here and I get to a zip package that I then download by clicking. Austria shapefile. Let me just look at this show in folder in my downloads. I'll extract this. So right click, extract all. And in this extracted folder, there are really 3 sets of maps. Austria at a 100 kilometer resolution, 10 kilometer resolution, and 1 kilometer resolution. I'll use the 100 kilometer resolution as it will upload the fastest. Okay, I have this. Let's now look for a shapefile for Saudi Arabia. Saudi Arabia shapefile. This earthworks.standard.stanford.edu. I click this link. Sometimes looking for a shapefile takes a bit of exploring. In these cases, I know these two links will work. And I'm looking for number 5, boundary of Saudi Arabia. I click here. Let me go to downloads and then original shapefile. Okay, it's also a zip file, so I'm going to show in folder. And I'm going to extract. It's just called data. So extract all. I have a folder called data that has many different files in it. Let's go back to Google Earth Engine. If we come over to the left, I'm going to go over to Assets. And I'm going to New, Table Upload Shapefiles. Select. I'm going to first update the upload the Austria shapefile. So I said we'll do this at 100 kilometers. It will simply upload faster. For your own purposes, upload whatever resolution or whatever files you have. We are going to upload 4 of these files. We're going to upload them. So holding Control, I'm going to select the SHX file, the SHP file, the PRJ file, and the DBF file. If we look at the type, we see they match. So DBF, DBF, PRJ, PRJ, SHP, SHP, SHX, SHX. Great. All for the 100 kilometer. Open the asset ID. I'm going to change the name just because to practice before I already downloaded these and uploaded them. So I'm just going to call it Austria. Austria. And I'm going to go upload. Now my face might be blocking this, so let me just drag this screen a bit here. This tasks tab became yellow because now you'll see just this line here, it's working. It is working to upload the data I just asked it to upload. So it's still running. While it's running, let's also ask it to upload the Saudi Arabia shapefile. So then, familiar now, new table upload shapefiles, select. Now, when I downloaded from Saudi Arabia, it was just in the folder called data. Okay, same thing before, but a little bit less organized here. I want to upload 4 files, the SHX, holding Control, SHP. See, this one's SHP, but called XML. So I want the actual SHP file, I want the PRJ file, and I want the DBF file. And the SHX file has the same, in this case, name as the other folders we have, as the other files we have. So 4 files, DBF, PRJ, SHP, SHX. Open, I'm going to call this Saudi Arabia. Upload. Okay, now we see here in tasks, I have this one we just finished. Austria has finished. Phase completed. Saudi Arabia will also complete. Will take about a minute. Okay. Okay. Now we want to look at the change in terrestrial water storage through time, and we're going to demonstrate this with a line graph. We will use this for Google Earth Engine. So search for ui.chart.image.series. Okay. ui.chart.image.series. I see some example code here. Starting from the bottom, let us take all of this. We won't use much of it, we'll delete some of it, but it'll just be an example that we can then work from. So right click, copy. So I'm copying the example from ui.chart.image.series. Take this over here. Let me close this, I don't need this now. And I'm going to paste it in here, Control V. I'm also going to drag this down as we're not using the map right now. And the tasks are finished. Okay. Okay, now coming back to our tasks actually. So this is our completed task, Austria. I'm going to view asset. Okay, over here there's delete, share, and there's import. I hope my face isn't covering it, but there's import. Let's click on import. Great, we now see it up here, and it's called table. It's called var table. I'm gonna recall it Austria. Perfect. Now let's import our Saudi Arabia. So drag this down, view asset, and then I'm going to click import. Okay, import. I have this other one table called with Saudi Arabia in here. So I'm going to recall this, what is now table, to Saudi Arabia. Okay, so I have two imports, Austria and Saudi Arabia. Close this, close this, close this. All right, our image collection. So now this is the sort of basic example we had for ui.chart.image.series. UI being user interface, I assume. Image collection is going to be this. It's going to be this equivalent water thickness CSR. So I'm going to take this, copy it, and put it in place of what is now image call. Great. The region, let us first use Austria. So my var Austria, I'm just going to, instead of region, write Austria. The reducer is the mean. This means all the cells from the Grace product that are intersecting with Austria will be averaged together at every moment in time. This is exactly what we want to use for this example. I'm going to delete scale and X property. We don't need these, so remove these. Okay. We're not gonna have the set series name, so we can also delete this. And set options, title. Let's change the title to change in water storage from Grace. Now we're doing Austria. The horizontal axis is date. This tile text style is fine enough. The vertical axis, if you go back to Grace Monthly Masquerades, we have description, we have bands. Okay, when we go to bands, we see that we are using centimeters. So let's come back here, and in the vertical axis, let's say it's change in centimeters. Let's also delete this line width, colors, and curve type. I'm keeping these commas in. I think they're fine. We'll see in a moment. Let's change in water storage. Okay. Now we see this date filter. We're going from the 1st of August to the 30th of August. Coming back again to the Grace information, if you scroll up, you see the dataset availability is from April 2002 to July, or I guess January 2017, the 7th of January. Let's take this complete time period in. So, instead of this, let's take 2002/04/01 with the end date. 2017 0107. Okay, that's what I want to do for now. So now I'm going to run. And we see the console has been highlighted yellow. Okay. Let's just run it again. Depending on the size, it makes the chart appropriate for the size of the console column. So here is the change in terrestrial water storage through time for Austria. One more change before we look at the graph. Come back to description. We see the GRACE monthly mass grids dataset is produced by 3 centers, CSR, GFZ, and JPL. Each center is part of the GRACE ground system and generates level 2 data used in this dataset. So the 3 datasets may be somewhat different. So let's just look at the outputs from all 3 centers. If I go to bands, I see this is the one we're currently using, just from the example. You can see it right here. So let's just use all of them. So the other ones look the same, just with GFZ or JPL at the end. So I come back to Google Earth, and under dataset.select, I'm just going to include the other 2 beside this one. So comma, the name in quotations, instead of CSR, I do GFZ. Comma, include JPL. Okay, so I make this a bit bigger. So data.select, I have the CSR, the GFZ, and the JPL. Okay, I'm going to hit run. Okay, dragging this over. You're going to see that this is going to be created, and then we're going to have this pop-up button, pop-out button. Hit this pop-out button, maximize the screen again. So again, this is the change in water storage from GRACE satellites over Austria from 2002 to 2017. So this is the change in water storage in terms of centimeters relative to the 2004-2010 time period. You can think of this that the average mass from 2004 to 2010, and what these represent is the change from, or the difference from, that average mass over Austria. So we see at this point in 2006, it is 12 centimeters in water higher than the average mass, or the average water quantity, the average water quantity over the 2004 to 2010 period. Just looking at this, we don't see any strong increasing or decreasing trend, let's say. And the 3 outputs, let's say, are capturing definitely the seasonality very similarly. Let's create this now for Saudi Arabia. What we'll have to change? The title. Make this now Saudi Arabia. Unnecessary, but easier to organize ourselves. And here, when it comes to region, my title here is Saudi Arabia. Saudi Arabia. And let's run this one. Saudi Arabia is much bigger than Austria, so this will take somewhat longer. But also relatively quick. I'm also going to push up this pop-out button. So this is the change in water storage over Saudi Arabia, again 2002 to about 2017. Now looking at this, we do see a decreasing. We also notice the numbers. So the influx that comes, so Saudi Arabia has rainfall, although relative to Austria, significantly less. So we see a sort of seasonality, although the seasonality is much more obvious when it comes to Austria. So the increase in water storage is coming from snowfall and rain that is happening in the wetter periods, and then the evapotranspiration and runoff that is happening from Austria is resulting in the decline in water storage. So here, a very clear seasonality, no clear increasing or decreasing trend, at least just visually. And here we see a seasonality, somewhat less agreement between the three different centers, but a clear decreasing trend. There is this fun peak at the end. One last trick is when you do the pop-up button, you can download the CSV. It'll come, if you have Excel, we'll open up in Excel. Let me take these two columns and make a chart out of them. So line graph. Okay, very similar to what we just saw. It's plus button, and I can do a trend line, add a trend line, so we see the decrease. But just for the slope of the decline, we can display equation on chart. Somehow that's interesting to compare differences and decreases. So for Saudi Arabia, we see a clear declining trend, at least according to this center, but for all centers. We can do the same thing for the Austria fluctuations and changes in water storage, and find that there's a slight decrease, but perhaps certainly not as significant as this decline in water storage.